A positive point charge Q is located at the center of a sphere of radius r. Let's draw it. In this problem, the radius is 0.8 meters. And it also says that the electric field is measured to be 850 newtons per coulomb on the surface of that sphere. Let's draw the electric field vectors. They would point outward because this is a positive charge. We want to find the net charge enclosed within the sphere's surface. So in other words, find QENC. Let's use Gauss's law to answer this. Gauss's law says that the total electric flux will be equal to Q enclosed over epsilon naught. Now, how will we find the net electric flux here? We have to multiply the field strength times the area of the sphere. Because the field makes a 90-degree angle with the sphere's surface at all points, we can easily find that flux. All we have to do is substitute in the area of a sphere formula. So the area of a sphere is 4 pi r squared. We would now want to plug in and see if we can solve for Q. So we'll have 850 for our field strength. Our surface area will be 4 times pi times 0.8 squared. And epsilon naught is 8.85 times 10 to the minus 12. Solve this equation for Q. I get 6.05 times 10 to the minus 8 coulombs. That is the charge enclosed by the Gaussian sphere.